Hi everyone, I'm Cheryl. In this problem, we're going to approximate the area of the region bounded by the curve y equals 1 over x equals 1, x equals 2, and y equals 0 right along the x-axis using upper sums and lower sums. In this particular problem, we're asked to use 5 subintervals. So we're going to begin by taking my interval from 1 to 2 and splitting it into 5 equal pieces. So I'm going to mark it off approximately in 5 equal pieces. Okay, from these pieces, I'm going to create rectangles. Now I notice that my function is a decreasing function. So if I create a rectangle whose height uses the left endpoint of my interval, it's going to overestimate the area. That means I'll be calculating my upper sum. So let's take a look at that first rectangle. So I'll come straight up to my graph, move over, and then come down. And again, notice what I've done is I've created a rectangle whose area is bigger than the piece that's under the curve. I'm going to continue to do that for the other 4 pieces. So on my next subinterval, I'll use the left endpoint, go up to my function, come over, and down. For the next subinterval, again, I use my left endpoint, come over and down. Again, the next subinterval, I'll use my left endpoint, come over and down. And finally, on my last subinterval, I'll come over and down. All right, so now I need to calculate the area of these 5 rectangles. That's called my upper sum. So the upper sum is going to be equal to the area of each of these rectangles added together. So let's take a look at that first rectangle. All right? To get the area of a rectangle, I'm going to need the height times the width. Well, before I get too far, notice that the width of all of my rectangles are going to be the same. I can calculate that by saying that delta x, or the width, is going to be b minus a all over the number of rectangles I use. In this particular case, 2 minus 1 all over 5. So each rectangle will have a width of 1/5. So the height of my rectangle is going to be the value of the function when x equals 1. So this will be f of 1. And the width is 1/5. Again, height times width. That's the first rectangle. I move to the second rectangle. The height is going to be the function value at this location. Well, if this is the value 1, which is the same thing as 5 over 5, this is going to be 6/5. So it's going to be the value of the function at 6/5. So f of 6/5 times 1/5 for the width again. Length times width. All right, third rectangle. Well, I need to use the function value at that left endpoint. Well, that's going to be at 7/5. So I'll have f of 7/5 times the width, which is 1/5. I'm going to continue to do that for the next rectangles. And notice that this one is going to be at 8/5, and this last rectangle will be at 9/5. So I'll have to add in f of 8/5 times 1/5 plus f of 9/5 times 1/5. Now let's just count up to make sure I have the proper number of rectangles. I should have 5 of them. 1, 2, 3, 4, 5. Okay, so now I have to do some function evaluation. What is f of 1? Well, my function is 1 over x, so 1 over 1 is 1. So I've got 1 times 1/5. f of 6/5 is 1 over 6/5, or 5/6 times 1/5. And in a similar way, I'll have 5/7 times 1/5 plus 5/8 times 1/5. And finally, 5/9 times 1/5. Now we need to do some arithmetic. I'll have 1/5 plus 1/6 plus 1/7 plus 1/8 plus 1/9. Because notice in each of these, the 5s will cancel. All right, so I'm going to use a calculator to get an approximation for this. It might be worth noting if you did the fractional arithmetic, you're going to end up with 1,879 divided by 2,520. But if I plug that into my calculator, we'll say that this is approximately equal to 0.75 for the area of my upper sum. Okay, now we need to start all over again and get the lower sum. So I'm going to go back to my picture. And remember how I split this into subintervals? I'm going to do exactly the same thing and split it in exactly the same way. So I still have my interval split at 1, 6/5, 7/5, 8/5, 9/5, and 2. However, because my function is decreasing, if I look at each individual subinterval and use the right endpoint to create my rectangle, let's see what happens. So in this interval, I'm going to go up to my function value and across using the right endpoint. Notice what happens is I've created another rectangle, but this time the rectangle's area is smaller than the area that would be under the curve. So I'm going to do that for each of the other rectangles. So again, looking at this subinterval, I'm using the right endpoint. So I'll go up to the function and over. Second subinterval, up to the function and over. Up to the function and over, and up to the function and over. And notice what's happened. I've got all these rectangles whose area will be smaller than the area under my curve. Okay, so now we're going to calculate the lower sum. So the lower sum, again, is going to be the sum of the areas of those rectangles. This time we're using the pink rectangles. So we need the height times the width. This time the height of my rectangle is calculated by the function value at my right endpoint. So that's going to be f of 6/5. And then of course I need to multiply by the width, which is 1/5. Okay. For the second rectangle, again, I'm going to use the right endpoint. So that's going to be f of 7/5 times 1/5. For the third rectangle, I'll use the right endpoint again, and I have f of 8/5 times 1/5. The next one will be f of 9/5 times 1/5. And that last rectangle, notice that the right endpoint is 2, so I'll have f of 2 times 1/5. Now again, let's just check and make sure I have the right number of rectangles. 1, 2, 3, 4, 5 of them, and I have 5 rectangles. So now it's time for function evaluation. F of 6/5 is 5/6 times 1/5. Then f of 7/5 is 5/7, and I multiply that by 1/5. F of 8/5 is 5/8, and I multiply by 1/5 again. F of 9/5 is 5/9, and I multiply by 1/5. And finally, f of 2 is going to be 1/2, and I multiply by 1/5. All right. Again, some arithmetic. There's going to be a lot of cancellation with the 5s as before, so I end up with a 1/6 plus 1/7 plus 1/8 plus 1/9, and that last piece is going to be 1/10. Okay, you can get a common denominator for this one. It's also going to be 2,520, but the numerator is going to be 1,627. And I can use my calculator to get a decimal approximation for this. So 1,627 divided by 2,520, and I get approximately 0.65. So what that's telling me is the area under my curve is going to be bigger than 0.65 square units, but smaller than 0.75 square units. I hope that was helpful. Thanks.